Distance is a measure of length. When we're looking at the distance, and we're considering the distance between 2 points on a graph, it's not quite as simple as just trying to count the boxes, right? Because this line doesn't really go through the boxes, so you can't really count them in that manner. But what we can do is count these boxes. This horizontal line has a length of 4. We can count these boxes, 1, 2, 3, 4, 5. This horizontal line has a length of 5. And what we have created here is a right triangle. A right triangle has the famous formula that goes with it, a squared plus b squared equals c squared. Right? This is the Pythagorean theorem. Oops, ran out of space. Now the Pythagorean theorem says a squared plus b squared equals c squared is what everyone remembers. A is here, b is here, c is here. When the Pythagorean theorem is involved, I actually don't like this formula. I like instead to use what is called leg squared plus leg squared equals hypotenuse squared. The legs of a right triangle are the two line segments, two sides that form the right angle. The hypotenuse is the one side that does not form a right angle, and it is situated opposite the right angle. So that's the hypotenuse. Again, so leg squared plus leg squared equals hypotenuse squared is what I like to use. Now, if we applied that here, let's call this other side d for distance. Excuse me. That's going to be 5 squared plus 4 squared equals d squared. Now, since we're doing the Pythagorean theorem, the legs get added together, which means they can be written in any order because addition is commutative. But if you, for some reason, put d and 5, let's say, in the wrong place, and you switch them, that would be incorrect. That's, again, why I like this leg squared business, because it doesn't really matter which order you write the legs in. 5 first, 4 first in this case, it's not going to make a difference at the end when you're calculating the distance d. So that's going to be 16 plus 25 equals d to the second power. I'm just going to switch this around because that's the way I like to see things. D squared is equal to 41. Now we can apply the square root property, right? That means d is equal to positive or negative square root of 41. From using the square root property, remember that plus or minus is mandatory when you're solving an equation and you take the square root property. The difference now, because this is a length, this is a distance that we are measuring. Distance cannot be negative, right? It's impossible to have a negative distance. So d is equal, in this case, to just the square root of 41. So if we were to take this Pythagorean theorem in a general case, d to the second power is equal to a squared plus b squared. Again, I'm just using a and b as the legs just for notation purposes. Now, if we were to solve for d directly, again, we would take the square root of both sides. D is equal to the square root of a squared plus b squared. Now, again, since we're talking about distance, I'm going to skip that plus minus business that usually needs to be there. And this is a formula that calculates d, the distance, directly. So let's re-look at these 2 points and the distance between them. If you haven't noticed, these points have ordered pairs. 8, 7 is the point on the upper right. 4, 2 is the point on the lower left. And what we did before was, again, drew these 2 lines, one vertical, one horizontal, creating a right angle. And we counted the boxes to find that distance. This ordered pair 8, 7, and this ordered pair, 4, 2, are two different ordered pairs. Now, is there another way we can find this distance horizontally without counting the boxes? Maybe we don't have the line graphed in front of us, so we can't count them. So here's what we can do, right? This is an x value of 4. Over here is an x value of 8. This is x1. This is x2. So 8 minus 4 is equal to that value of 4. If we look at the y values, up here is 7. Down here is a y value of 2. That's y1, and that's y2. And 7 minus 2 is equal to 5. Again, the distance, if we were counting boxes, the same. So this formula of d equals a squared plus b squared inside a radical can be rewritten as d equals x2 minus x1 to the second power, because that is the same as this, plus y2 minus y1 to the second power, because y2 minus y1 is the same as this subtraction right here. And this is again inside the square root. And this right here is your distance formula. If you want to find the distance between 2 points on a graph, you're going to use this formula right here in order to do that, presumably because you have the two ordered pairs. Now let's take a look at 3 examples on how we can apply this formula. Number 1 is pretty straightforward. Find the distance between 2 points, and we're given 2 ordered pairs. Now when this happens, when we are given 2 ordered pairs and we need to find the distance between them, and I do this for the slope formula as well, you have seen me do it in class, I like to label one of the ordered pairs x1, y1, and the other ordered pair x2, y2. Sorry, I messed that up. x2, y2. Now, it doesn't really matter which one you label, 1 and 2, just as long as you are consistent and you are keeping 1 and 2 in the same ordered pair, right? So x1, y1 can be 3, negative 4. It could also be negative 4, 1, and your answer will remain the same. But I usually keep it consistent. The first one is x1, y1. The second one is x2 and y2. So our distance formula, which I rewrote here, can read negative 4 minus 3 plus 1 minus negative 4. One thing I want to highlight here is take a note that we're subtracting a negative 4. So that's going to be minus a negative 4. There's 2 minus signs there. One from the formula and another one from this plug-in being a negative number. So d is equal to negative 7 to the second power plus 5 to the second power as a result of that subtraction. And that's going to be equal to 49 plus 25, and it's all inside the radical. And that means d is equal to the square root of 74. And if this is a perfect square, then simplify it. But since it's not, then we can leave this alone. Now let's look at another one a little bit more involved. We're given 3 points. A is negative 3, 4, B is negative 6, 6, C is 3, 13. And we need to determine whether these 3 points create a right triangle. I have graphed the 3 points right here, and what they're asking is that if you were to draw a triangle at these 3 points, is this triangle indeed a right triangle? Now there's a couple ways to do this, but we're going to use distance in order to figure that out. Now if this is true, indeed a right triangle, that means this length here, AC, and this length AB, and that means this length BC. That means these lengths have to satisfy the Pythagorean theorem, a squared plus b squared equals c squared, or rather again, what I like better, leg squared plus leg squared equals hypotenuse squared, right? From this diagram, it's kind of difficult. Again, it's not drawn to scale. I kind of freehanded it. So you can't really determine what's the legs and what's the hypotenuse right now. So let's do the distance formula first. AB, again, that's the distance between points A and B, is going to be -6 minus -3. Again, notice that there's parentheses around that second substitution, plus 6 minus 4. And I'm being a little lazy here. I should put parentheses here around that second substitution. And let's apply the distance formula to this. That's going to be -3 to the second power plus 2 to the second power, which is going to equal the square root of 9 plus 4, which is going to equal the square root of 13. Now we're going to repeat this for B and C. That's these two. And then we're going to repeat it again for AC. That's A and C, those two. And I've done that right here. Plugged in the appropriate values. So we got the square root of 130. Plugged in the appropriate values for A and C. And then we got the square root of 117. Now, one thing that is important to know here is that the hypotenuse of a right triangle equals the longest side, which means biggest distance. So which one of these, AB, BC, or AC, is the biggest? Well, that would be the square root of 130. So this is what we can mark as our hypotenuse. And if this is our hypotenuse, that means our legs are those two sides. So let's determine whether these three sides actually satisfy the Pythagorean theorem. A squared plus b squared equals c squared. Again, leg squared plus leg squared equals hypotenuse squared. One of the legs is equal to radical 13. So let's raise that to the second power. One of the other legs is equal to radical 117. Let's raise that to the second power. And then this should equal our hypotenuse, which is radical 130 raised to the second power. Anytime you square a radical, what you're left with is just what's inside. 13 plus 117 equals 130. Now, this is a check, which means we are trying to determine whether this equal sign is actually true or not. That means the left side must meet the right side. 130 matches up with 130. This is not an equation. This is an evaluation where we make sure that they both match. So yes. Ooh, that's not 1130. That is 130. So since 130 matches up on both sides, then yes, these 3 points actually create a right triangle. And this is the proof right here. Next up is being given the diameter of a circle as points on a graph. Now you don't have to graph it, just like with the previous problem. You didn't have to graph it. But what's happening here is we have these 2 points that were given. And we're being told that these 2 points actually form the diameter of a circle. That means right in the middle of this line, is the center of the circle. That means the distance of half of this is the radius of the circle. Now remember, in order to write the equation of a circle in standard form, that equation has to be x minus h to the second plus y minus k to the second equals r to the second, which means the only things we need to know is the location of the center as an ordered pair and the size of the radius of the circle in order to complete this problem. So let's figure out the easier one first, which is if the length of the diameter, if we can figure that out, that's going to be equal to negative 20 minus 4 to the second power, because this is x1, y1, this is x2, y2, plus 3 minus 13 to the second power. This is equal to negative 24 to the second plus negative 10 to the second. Anytime you square a negative, remember the result is positive, so that's going to be a positive 576 plus 100, which means we have a square root of 676 as our distance. This is actually a perfect square. Square root of 676 is equal to 26. So we have a diameter equal to 26. We have, that means our radius equal to 13. So what we're saying here is that this radius is equal to 13, and we can use that for our equation. But the next thing we need to figure out is the location of the center of the circle. So let's figure that out right now. There is something called a midpoint formula. The midpoint formula has this to go with it. x1 plus x2 divided by 2, y1 plus y2 divided by 2. And what that means is that we can actually, knowing these two ordered pairs, we can pinpoint this point right in between them, called the midpoint. So let's figure that out based on the x1 and y1, x2, y2 that we were given. That's going to be 4 plus negative 20 divided by 2, comma, 13 plus 3 divided by 2. So that's going to be negative 16 over 2, and positive 16 over 2 as our x and y values. Negative 8, positive 8 is the center of the circle. So remember, our equation of a circle, x minus h squared plus y minus k squared equals r squared. This means that the center of the circle is equal to h comma k, and the radius of the circle is equal to the square root of that number. So if we were to do this in reverse, knowing that the center of the circle is located here, negative 8, positive 8, that means x minus negative 8 to the second plus y minus 8 to the second. That's basically doing x minus the first number and y minus the second number. And this is equal to 13 to the second power. Remember, when we take the radius, we take the square root. So if we know the radius and we're putting it into the formula, the equation, then we have to square it. So that's going to be x plus 8 to the second power plus y minus 8 to the second power equals 169. And this is our standard equation of a circle. Thank you for watching, and I hope this was helpful.